Welcome to Brain Vision.
Okay, let's start off by drawing the scene here. We have a ladder propped up against a wall, and it is making a 30-degree angle with the wall, which I will denote with theta here, and let's write down that theta is equal to 30 degrees. And we have a painter who has a weight of 75 kilograms that wants to go up the ladder 2.75 meters, which will be our displacement S. And if we draw out the force diagram of our painter here, as he's going up the ladder, he's going to have a gravitational force pointed downwards and a normal force which will be perpendicular to the ladder here. So make a small dotted line to represent the plane of our ladder. And I'm going to align my reference frame, in this case, X and Y, with the ladder. So in the first part, A, it's asking us to calculate the work due to the gravitational force. So we have the magnitude of the force of gravity times the magnitude of our displacement, which we are given, times the angle between them. So we see that this is pointed straight down. And if we think about our triangle, we have 90 degrees there, theta, which is 30 degrees, 90 degrees here. So to complete this triangle, this means that this angle is 60 degrees. So our angle between the displacement going up the ladder and the gravitational force pointing downwards would be 90 plus 60 degrees, which is 150 degrees. And so we substitute in mg for the magnitude of our gravitational force, and we have the cosine of 150 degrees still here as our angle, and now we're ready to plug in the numbers into our expression. So we have a 75 kilograms as the mass, 9.8 meters per second squared for the acceleration due to gravity. The displacement is 2.75 meters, and cosine of 150 degrees. And when you multiply all those together and round off to the proper number of sig figs, which would be 3 in this case, you get that the work due to gravity is negative 1750 joules, or 1750 joules. And so this makes sense since the man is moving upwards and the gravitational force is pointed downwards, that you're going to end up with negative work done by the gravitational force. In part B, it asks, does the answer to part A depend on whether a painter climbs at a constant speed or accelerates up the ladder? If we look at our expression for work, it's only dependent on the magnitude of the displacement, the magnitude of the gravitational force, which is only dependent on the man's mass and the gravitational acceleration, and then the angle of them will not change based off of the man's velocity or acceleration. So in this case, we have a no, and work done by gravity will be independent dependent of motion.